All right, for today's Zoom lesson, we're going to go over prime factorization and greatest common factor. So to start with prime factorization, let's review a little bit of our vocab from last week. Last week we talked about prime numbers being the numbers that only have two factors. So some of our prime numbers were 2, 3, 5, 7, 11, 13, 17, 19, and 23. And then they can keep going. And then factors were numbers that could divide out of whatever number we're comparing, or the numbers that multiply to get the number we're looking at. So when we look at prime factorization, we're looking for the prime numbers that can multiply to get us whatever number we're working with. We had 36, for example, and we want to prime factor it. We're going to use what some people call a factor tree, and we're going to factor it out. When we want to do prime factorization, we need to pick two numbers that can multiply to get our number, so two factors, and we don't want to pick the factor 1, so we don't want to do the pair that's 1 times 36, but we might do 6 times 6. Or we could do 3 times 12. Or 4 times 9. Any two numbers that get us 36, it doesn't matter which two we pick, as long as we pick one pair that gets 36. Now we're going to take these two numbers and break them down into their prime factors. So 6 breaks down into 2 times 3. And since one 6 does that, then the other 6 does that. And I'm putting multiplication dots in between each number so that I can keep them separate. If I didn't have it there, I might wind up later on looking at this and thinking that's a 23. Looking at our numbers, 2 times 3 is prime. So these are all prime numbers. I'm going to circle my prime numbers. Since each of these are prime, my prime factors for 36 are 2 times 3 times 2 times 3. If we were doing greatest common factor is where we compare two numbers. And looking at the name greatest common factor, we're comparing the biggest shared factor. And we can do this using prime factorization. So when we're using prime factorization to find greatest common factor, we have two numbers or more that we're comparing. So here, I've already factored out 36. So we're going to compare 36 and another number, 54. We're going to factor out 54 just like we did with 36. So two numbers that can multiply to get 54. And we can do 6 times 9. Neither of these numbers are prime, so we need to break them down into prime numbers. 6 breaks down into 2 times 3. And 9 breaks down into 3 times 3. All of these numbers are prime, so I'm going to go ahead and circle them. And the prime factors for 54 are 2 times 3 times 3 times 3. When I'm looking for greatest common factor, I'm gonna circle the prime factors that they have in common, our two numbers have in common. So 36 has a 2, 54 has a 2, so that's a 2 they have in common. I'm gonna write these up top. Since they have a 2 in common, I'm putting 1, 2 here. 36 has a 3, and 54 has a 3 that matches, so I'm gonna put a 3 up here. 36 has another 2, 54 doesn't have that 2, but 36 has another 3, and 54 has another 3. So we have 1 shared 2 and 2 shared 3s. To get the greatest common factor here, we're going to multiply this out. So we've got 2 times 3 times 3. 3 times 3 is 9, and 2 times 9 is 18. So our greatest common factor is 18. Let's do one more. Let's compare 100 and 168. Got 100 and 168. We're going to factor these out. 100 could break down into 4 times 25 or 10 times 10. 4 and 25 are both composite numbers. They're not prime, so I'm going to break them down. 4 breaks down into 2 times 2. 25 breaks down into 5 times 5. 2 is prime and 5 is prime, so I'm going to circle those. My prime factors for 100 are 2 times 2 times 5 times 5. All right, now I'm going to break down 168. And off the top of my head, I don't know what times what gets me 168. So if you ever run into that, you can look at your number and say, okay, is it even? Does it look like it's divisible by 3? And kind of go down the 1 through 10 list until you find something that can come out. This number's even, so I'm going to divide it by 2. 2 can't go into 1, but 2 can go into 16. And that goes in 8 times. 2 times 8 is 16, so if we subtract, we get 0. We bring down our other 8. 2 goes into 8 4 times, and 2 times 4 is 8. So we're left with a remainder of 0. 2 times 84 is 168. And now we can circle our 2 because it's prime. But my 68 or my 84 is not prime, so I need to break it down. 84 could break down into 2 times 42. Half of 84 is 42. That 2 is prime, but my 42 is not. 42 can break down into 2 times 21. 2 is prime, 21's not. And 21 breaks down into 3 times 7. 3 is prime and 7 is prime. My prime factors for 168 are 2 times 2 times 2, the 3 2's, times 3 times 7. Now, to get my greatest common factor, I'm gonna pull out what they share. So 100 has a 2 and 168 has a 2. So that's 1, 2. 100 has another 2 and 168 has another 2. So that's 2 2s. 100 has a 5, but 168 doesn't have a 5. And then 100 doesn't have any other 2s, a 3, or a 7. So the common factors, or common prime factors, are 2 times 2. And if we multiply those out, our greatest common factor is 4. All right, if you'll have any other questions on greatest common factor, let me know. Next week, we're going to go over least common multiple. And then we'll start getting into the actual fraction stuff. You'll have a good day.